In this video, we are going to go over section 4.3, L'Hopital's rule. L'Hopital's rule is used to find the limits of a function that are in indeterminate form. Indeterminate form means when you plug in a number to evaluate limit, you get a 0 over 0 or infinity over infinity. So in the past, in Math 122, when you evaluate limit and you get 0 over 0 or infinity over infinity, we couldn't find the limit. Now I'm introducing a new rule called L'Hopital's rule. So whenever, even if you have a 0 over 0 or infinity over infinity, you can still find the limit value. So here's the theorem. L'Hopital's rule for 0 over 0 indeterminate form. First, this condition has to meet. You plug it in value c for the limit as x approaches to c. F of x is a 0, which means the numerator 0, and then also the denominator 0. So you first check and see if you get 0 over 0 when you plug it in value c. If that happens, you can, and this is L'Hopital's rule, you can take the derivative of function f, take the derivative of a function g, and then apply the limit value c, and that will be your limit function value. L'Hopital's rule for indeterminate form 0 over 0 are also valid if you have infinity over infinity. So it's very simple. Once you have a 0 over 0 or infinity over infinity after you evaluate it, then you can apply L'Hopital's rule by taking the derivative of each numerator and denominator and plug it in c. So we are going to be working on couple problems together. And on the side of the right side, I also write down related homework problems. So I'll do exam problem 1, and this can be related to the My Math Lab homework number 1 and number 2. So you can use these notes to compare with homework problem and then approach similarly. So let's begin with number 1. So we have a limit as x approaches to 3, x cubed minus 27 over x squared plus 2x minus 15. Now, if you were to approach this traditionally, you would plug it in 3 into this on the numerator and then 3 on the denominator. So let's do that. If I take limit and then, if I take limit and then apply 3, you have a 3 cubed minus 27, and then 3 squared plus 2 times 3 minus 15. Well, 3 cubed is 27. 27 take away 27 is a 0. 3 squared is 9. 9 plus 6 is 15. Take away 15 is a 0. So you get this indeterminate form, 0, 0. So once you have an indeterminate form, I can apply L'Hopital's rule. So L'Hopital's rule applies because you have an indeterminate form. So how do we find the limit of a x goes to 3 of indeterminate form? Very simple. You take the derivative of numerator and then derivative of denominator. And derivative rules we practice and then review the first week. This is the reason why we begin with reviewing the concept of derivative. And then we plug it in c. So let's try this. So derivative of x cubed minus 27, that's very simple. That's the power rule. So you have a 3x squared. Constant is a 0. This will be 2x plus 2, and then again 15 is a 0. Derivative of constant is a 0. Apply, so we have done derivative. Now simply plug it in 3. So 3 times 3 squared over 2 times 3 plus 2. So I'm also going to put L'Hopital's rule here. Okay, that's my way of knowing, oh, I didn't change the problem, I just applied the L'Hopital's rule. So I'm going to have 27 on the numerator, and denominator is 6 plus 2, 8. And that's it. This is the answer. Okay. So first check and see if you get an indeterminate form when you originally plug it in the given value. once you have the indeterminate form, you can just take the numerator on the top, and you can take the derivative on top, derivative on the bottom, and then plug it in the value. So let's try number 2 together, and then you can use this one to answer question number 3 and 4 on MyMathLab homework. So again, I'm gonna check and see if we get an indeterminate form. So if I plug it in infinity here, well, 3 times infinity to the fourth power plus 7 is just really large number. Same thing here. If I plug it in infinity, you get infinity to the fifth power times 6 plus number. I'm gonna get another infinity. So we do have an indeterminate form where f and g are both infinity. So that means I can apply L'Hopital's rule. So here's where actually the problem begins. So I'm going to take the derivative of both top and the bottom function. That's what the L'Hopital rule is. So if I take the derivative of top, I'm going to get 3 times 4, because 4 comes down, power rule. So 12x cubed, 17, it's just constant, so 0. And I'm going to get 30x to the fourth power. Now we apply the derivative, okay? And then you can plug it in. Well, so I'm going to have this bottom heavy function. So recall that we have denominator power is higher than the numerator power. So this is going back on the limit on chapter 2 of Math 121. So you have x to the fourth is greater than x cubed. When you have a bottom heavy, when you apply the infinity, what happens? We get 0. Another way to recall this is you can also divide it by the highest power, so limit as x approaches to infinity. If I divide it by x cubed on both top and bottom, so 12x cubed divided by x cubed, 30x to the fourth power divided by x cubed, I'm going to get 12 over 30x. Don't forget the limit. Oops. Limit as x approaches to infinity. So you can definitely see that you have 12 on the numerator and you get really big numbers, so you end up getting 0. So either way works. If you remember the property where denominator power is greater than the numerator, bottom heavy, the limit function is 0, or you can divide by each top and bottom by x cubed, and you can see that you're going to get the same answer. Okay. On the next page, we have a couple more example. So let's try number 3. Explain why L'Hopital's rule does not apply to the following problem. If the limit exists, find it by other means. So here, both of them applied because we have an indeterminate form. 0 over 0, infinity over infinity. So if I do same approach and I apply a number 4 into each numerator and denominator, then I'm going to get 2 to the fourth power, raise it to third, minus 35 over 3, 4 squared plus 5. Well, the top will be 93, bottom 16 times 3 plus 5, I'm going to get 53. So here, you can see that L'Hopital's rule does not apply because when the value is substituted into the function, the result is not 0, 0. So the answer is just 93 over 53. Let me write a comment. L'Hopital's rule does not apply because when the value is substituted into the function, the result is not 0, 0. So again, the only time you can apply L'Hopital's rule, which means take the derivative of top and bottom, when you have indeterminate form, either 0 over 0 or infinity over infinity. Okay. Number four is actually coming directly from your homework problem. This is your number 7 on the homework problem. I also include this one so that you guys can follow this notes to try number 7 as well. I tried to pick a couple problems from homework too. So here, find the limit of the following. Use L'Hopital's rule if applicable. So which means if you have an indeterminate form, we'll use L'Hopital's rule. So let's try this one. So limit as x goes to 4, ln x minus 3 over x minus 3. Well, let's first begin plug it in to see if we get indeterminate form. If we apply 4, we get ln of 4 minus 3 over 4 minus 3. So that is ln of 1 over 1. ln of 1 is 0 over 1, which is 0. So this one, same thing happened with number 3. L'Hopital's rule does not apply because the value is substituted into the function. When the value is substituted into the function, we do not get 0 over 0. We get 0. So therefore, the final answer is 0. Okay. Moving along with number 5. So number 5, just keep practicing this L'Hopital's rule. Okay, can we use L'Hopital's rule? Then we use it. If not, the limit function is simply the evaluated function. So in problem 5 through 8, find each limit. Note that L'Hopital's rule does not apply to every problem, and some problem will require more than one application of L'Hopital's rule. So we apply so far just once. Sometimes you can have more than once where we can use L'Hopital's rule. So you apply first time, and if you still get indeterminate form, you can continue to take the second derivative, third derivative until you actually get a value out. So L'Hopital's rule can be applied more than once in the problem. So let's take a look. Let's start with number 5. Number 5, we have limit as x approaches to -1, x cubed plus 7x minus 6 all over x squared minus x. And this example can be used to answer question number 8 on your homework problem. All right, so let's try. I'm going to first plug it in -1 to see if we get 0 over 0. Then we can apply L'Hopital's rule. If we don't get 0 over 0, well, then that's the answer. So plug it in. Let's check. -1 cubed plus 7 times -1 minus 6. -1 squared minus 1. Minus -1. So here I have -1 minus 7 minus 6 over 1. You have -1 squared, which is +1, minus -1, so 1. So I have on the numerator -1 minus 7 minus 6. I get -14. And then on the denominator, I have 2, which is -7. So you can see that this one, L'Hopital's rule does not apply. We don't get 0 over 0. So our final answer is -7. Okay. Let's go to the last page. We have 2 more problems to end the section. All right, number 6. Let's take a look at number 6. So again, I will be checking and see if it's indeterminate form. So I'm going to first plug it in infinity. Now if you plug it in infinity here, we get infinity plus infinity subtracts just small numbers. So in general, you're going to get infinity on top. Same thing here, infinity to the 4th power times 9, that's really big number. 6 times infinity plus 7, that's, well, you can see that this number on the first term will be a lot bigger. So even if we are subtracting this to this, we still get in generally some big number plus 7. So I'm going to also get infinity over infinity. So this one, L'Hopital's rule applies because we get indeterminate form, infinity over infinity. Now let's try continue the problem. So if L'Hopital rules applies, and I'm going to erase this one so we can see the actual problem better. We are going to take the derivative of the top function and then derivative of the bottom function. So derivative of top, that's a simple power rule. I'm going to get 21x squared plus 4 minus 0. 4 comes down times 9 with 36x cubed minus 6 plus 7. Well, that's a 0. Now let's take a look. Now same thing. If you apply the infinity again, right? Then we get infinity on top, and then also infinity because big number take away 6. So this is where we apply the L'Hopital's more than once. So I can still apply L'Hopital's rule for the second time because I still have indeterminate form. So I'm going to keep going. That means I need to take the derivative of top, which is 42x. And then bottom, so 3 comes down, so 36 times 3, which is 108x squared. Right, 36 times 3, 108x squared. Well, take away 6 is a 0. Okay. All right. So let's take a look. Now let's apply infinity. Well, 42 times infinity is infinity. 108 infinity squared is infinity. Again, this is indeterminate form. So that means I'm going to apply the L'Hopital's rule. So you can see that you can apply as many as you like as long as it's in indeterminate form. So let me make it small. size. Okay. So let's apply one more time. L'Hopital's second time. L'Hopital's now for the third time. Limit as x approaches to infinity 42x, derivative is 42. 108x squared is now 216x. Now let's apply infinity. Then I'm going to have 42, and then I'm going to have very big number. A number divided by really big number, in generally it's a 0. So my final L'Hopital rule doesn't apply anymore. My final answer is 0. Okay. So you apply the L'Hopital's rule, plug it in. If you get indeterminate form, you can continue to do it until you do not have an indeterminate form. Okay, this is the last problem, and this is actually coming from your homework. This is number 11, very last problem on the homework. Find the indicated limit. Note that L'Hopital's rule does not apply to every problem. Some problems require more than one, so it's a similar direction but different example. So let's take a look. We have a limit as x approaches to infinity, e to the negative x over ln 1 plus 7 e to the negative x. Okay. Well, let's first plug it in infinity. I'm going to get e to the negative x, the same thing as 1 over e to the x, right? Because negative power, you can rewrite it using positive power. Same thing here, 1 plus 7 e to the x. I just like to have a positive exponent. So if I plug in infinity, I have 1 over infinity. So on the numerator, that's just going to be 0. 1 divided by real big number is a 0. Okay. Now on the bottom, if I apply infinity, I'm going to have ln of 1 plus 7 over e to the infinity, which is infinity. Now this is a 0, so I'm really having ln of 1 plus 0, which is 1. So ln of 1 is also 0. So we have indeterminate form, so L'Hopital's rule applies. So let's continue. So I'm going to apply L'Hopital's rule and take the derivative of the numerator and take the derivative of denominator of our original function, which is this one and then this one. This one here, this one here. Derivative of e to the negative x, that let's recall that's chain rule, e to the x times e to the negative x of derivative of negative x, which is negative. So I get negative e to the negative x. Ln of 1 plus 7 e to the negative x. Now let's put that on side. Recall that ln of x, the derivative of ln of x is d dx of ln of x is 1 over x dx. Right? So if you have L, and this is a chain rule, so I'm going to have this whole thing on the bottom, and derivative of this chain inside, which is derivative 1 is a 0. 7 e to the negative x is negative 7 e to the negative x. So I'm going to have a negative 7 e to the negative x over 1 plus 7 e to the negative x. So this is, recall, this is coming from chapter 3 of last semester. All right, so my bottom one will be negative 7 e to the negative x over 1 plus 7 e to the negative x. I'm going to do a little bit of rewriting, make it simple. So I'm going to multiply the bottom by 1 plus 7e to the negative x. And then also top, if I multiply one thing on one side, I have to do the same thing on the top. So this is nice because this bottom one cancels out. On the numerator, I'm going to end up having limit as x approaches to infinity, negative e to the negative x, 1 plus 7e to the negative x. On the bottom, you have negative 7e to the negative x. So doing a little bit more simplifying, this over here can cancel out with this, giving me negative 7. The e to the x cancel out the negative. In fact, negative also cancels out each other. So I'm going to have 7. On the top, I have 1 plus 7e to the negative x. So limit x approaches to infinity, 1 plus 7e to the negative x over 7. So plug it in infinity now. I have 1 plus 7. This part over here really is 7 over e to the x. So I have 1 plus 7 over infinity over 7, which is really 0 here. 7 divided by really large number is a 0. So I get 1 over 7 as the final answer. Okay. That's it for section 4.3, and then we will move on to next section in the next video.